Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem statement it is maximum score from removing substrings. Okay, and the problem statement goes like this. So you will be given a string s, which and two integers will be given to you x and y. So on this string s, you can perform two type of operations any number of times you may like. So in the first operation, what you can do is you can remove the substring a b from the given string s. Okay, and removing each substring a b from the given string s will grant you, or you will be gaining x points. Okay, and the second operation is that you can remove substring ba from the given string s, and each removal of substring ba from the given string s will grant you, or you will be gaining y points. Okay, so you have to return the maximum points that can be gained after applying all any of the above operations in the most optimal order possible. Okay, so you have to return the maximum points which you can gain. Okay, so in a way you have to maximize your points. So let's have a quick look at the constraints also. So according to the constraints, the length of the string will be of order 10 raised to power 5, and x and y points will be of order 10 raised to power 4. Okay, and it is mentioned that s is having only lowercase English letters. Okay, so let's try to understand how we can solve this, or how we can maximize our points. Okay, so let's consider a scenario that a string is given to you. Let's say x y z, and then b, let's say a b a b, and then again x y z. Okay, so this string is given to you. So how you will be able to maximize your output? First of all, there are two considerations that you might want to take. So let's say x is given to be something, or x is, let's say, 2, and y is, let's say, 5. Okay, so removal of ba is giving you 5, and removal of ab is giving you 2. Okay, so let me check. Okay, x was for ab and y for ba. Okay, we are correct here. So let's say this is the string given to you. Okay, so but there is a situation here that you might want to consider when you will be maximizing your input. So for this particular string, let's write it separately. ab ab, you can see that two ab's are sharing one ba. Okay, so these two were ab's in separately, but they were sharing one ba. Okay, so you are in a dilemma. So either you can remove two ab's, okay, or you can remove one ab and one ba. Okay, if let's say you remove this ba, then your string will be this, and then you can remove this one also. Okay, so these are two options. Okay, option 1, option 2. So you can do any of either of these two. Let's consider this situation only. Here, as you can see, your x is less than or equal to y. Okay, so it's 2 and 5. So less than or equal to y. So here, if you remove two ab's, then what you will get? You will be getting 2x. Okay, points. Let's change the color here. So 2x points you will get if you go with the option 1. And if you go with option 2, then you will be getting x plus y points. Okay, but because of this equation, you will notice that x plus y is either greater than or equal to 2x. Because of this y is either greater than or equal to x. So because of this equation, you came to know that it is wise to always remove, wise, or you can say greedy, to always remove higher points giving substring first. Here it was BA. Okay, okay, so we can remove it. It is not a generic thing, it is only for this case. Higher points substring first and then lower points giving substring. Okay, I think uh, I overlapped with the video here. So let's take this to the next slide. Or let's take this entire thing. Just a second. Yeah, I think now it should be fine. So I was mentioning that it is wise to remove either the first the higher points giving substring and then lower points giving substring. Okay, so we have to remove uh, in this order in order to maximize our points. So this is a greedy approach. Okay, so the only concern for us is now how we will be removing these. Okay, so let's have a look at the implementation and then we will be trying to understand how we have implemented this removal. Okay, so let's take the implementation to the board. So let's take a fresh slide. Okay, so this is the implementation, and for our convenience, let's remove this toolbar also. Okay, so let's begin. So first of all, we should be determining which substring is giving us more benefit and which substring is giving us less benefit. So as we know that x was paired to AB and y points were paired to substring BA. Okay, then if x is greater than or equal to y, then you can say that the more benefit giving substring or the pattern will be AB, else it will be BA. Okay, and depending upon which substring or the pattern is giving you more profit in terms of points, your small benefit pattern will be decided. So if your pattern AB was giving you more profit, then we can know for sure that BA will give us small profit. Okay, so I think we are done with these two statements or lines. Then further moving down the implementation, then you will be removing the bigger point giving pattern first. Okay, removing more profitable pattern first. Okay, pattern is nothing but substring. Okay, so once you remove it, and you might ask what is the procedure of removal. So this is the removal procedure. So what you will be doing is, let's consider that scenario XYZ. Okay, let's consider something different. So DEF AB. Okay, and then DEF. So what we will be doing is, so we will be using a stack like structure. Okay, so we will be pushing everything onto the stack. Okay, although it is a doubly ended queue, I will tell you why we are using doubly ended queue, but right now it is behaving as a stack. Okay, so let's say then F is pushed, then A, and then you came to a point while you will be traversing this string from left to right direction at B. So you see that top of the stack is having A, which is the first character of your pattern, and your current character that you are visiting is the second character of your pattern. Okay, so in let's say the pattern was AB, so it was the first character, or you can say pattern 0, and this is pattern 1. Okay, so as you can see, uh, since it is forming uh, our pattern which is AB, so we will be removing the top of the stack. Okay, so A is gone, so let's remove A. Then only you are left with rest of the strings, so you will be pushing them DEF, and then you will simply know that your string is this way up. Okay, so this will be behaving as a queue now. So while this will be behaving as a queue, we will be getting D, then E, F, D, E, F. Okay, in this way. Okay, so till this traversal of the whole string that was given to us, which was text character by character, the string was behaving as a stack. And as when we were able to see that the top of the stack was consisting of your first character of your pattern, and your current character that you were visiting was your second character, in that case you removed the top of the stack, indicating that you are removing the pattern. Okay, so this will be done in the remove patterns method. Okay, once all things will be removed, a modified string will be given to you. Okay, so big pattern removed will be the modified string that will be provided to you by this method. Once you have get access to the modified string, then you can very easily count the number of pairs that you have removed. Okay, so the number of pairs that you have removed will be the original length of the string plus the minus the modified length of the string. Okay, so it will give you the number of characters that you have removed, and if you divide it by 2, since A and B both were of size 2, so it will give us, let's change color here, so it will give us the number of pairs of the given pattern that you have removed. Okay, and since this pattern was giving us maximum benefit, so we are taking maximum values among x and y and multiplying it with the number of patterns removed. Okay, and adding it to the maximum gain that can be achieved. Okay, so similar thing will be done with the now reduced string, which is the big pattern removed. Now we are removing the smaller more less profitable pattern. Okay, and here removing less profitable pattern. Then once we remove this less profitable pattern, We will again update our maximum gain by taking the minimum of x and y points and multiplying it with the number of smaller profitable patterns removed, okay, which will be as in the above statement also, which will be given by this uh, expression, okay, and then you will be simply returning your maximum gain. So this is the whole approach. So in terms of time and space complexities, if we consider, it will be time complexity wise, it will be order of n, where n is the number of characters in string, okay, and space complexity wise also you can say that it will be order of n because of use of this doubly ended queue. Once it was used as a stack, then it was used as a queue. So the time complexity is because of traversal of characters one by one. Two times we are traversing the whole string, or the you can say the modified string also, okay, and array dequeue or this stack is holding characters, so that's why order of n will be the space and time complexities. So I hope you are able to understand this approach. If you are having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Till then, keep solving more and more problems, and I will see you in the next video. Thank you for watching.